All right, so in our first 8 assignments during Unit 6, we talked about exponential rules and how to simplify exponential expressions. The last 3 units or assignments in this unit, we're going to be talking about exponential functions, actually describing patterns with equations that involve exponents. So let's go ahead and get started with our first example. First example talks about a rumor, and so suppose somebody starts a rumor about another person here at Homestead, which happens quite often. But first period, there's one person that knows about the rumor. And we're going to make an assumption that after each period, the number of people who know about the rumor triples. So after first period, there are 3 people who know about the rumor. And that's because we took the first person and we multiplied it times 3. After 2 periods, the number of people, again, triples. These 3 people go to their 3 separate classes, tell 2 people in their new class, and so there's 3 people in those 3 classes. That's a total of 9 people. Or we could think about it this way. We started with 1 person, and then we multiplied it times 3 to get how many people knew about the rumor after first period, and then we multiplied that times 3 again to figure out how many people knew about the rumor after second period. Another way of writing that is 1 times 3 squared. All right, after the third period, well, we're going to take 9 times 3. That's 27 people are going to know about the rumor. And so the way we could write this is we could take 1, which is how many people knew about the rumor at the beginning, and then we're going to multiply it times 3, 1, 2, 3 times. So it's going to be times 3 to the third power. After 4 periods, 27 times 3 is, let's see, that's going to be 81 people, because we would take 1 times 3, 1, 2, 3, 4 times. And you can see there's a pattern here. After 1 period, it's 3 to the first. After 2 periods, it's 3 to the second. After 3 periods, it's 3 to the third. After 4 periods, it's 3 to the fourth. So suppose we want to find out how many people are going to know about the rumor after 7 periods. If we skip down to 7 periods, I don't know what this is going to be yet, but I know the equation is going to be 1 times 3 to the 7th power. And if we take 1 times 3 to the 7th power, that's 2,187 people. That's almost, maybe a little bit under, the size of Homestead. So that means after one day, everybody's going to know about the rumor, maybe except for the people who are absent that day. And so what we want to talk about is this equation. The general equation here would have been the number of people who know about the rumor is going to be 1 times 3 to a certain power. This x changes. It's the variable, because after 1 period it's 1, after 2 periods it's 2, after 3 periods it's 3, after 7 periods it would be 7. So it's called an exponential equation because the x, or the exponent, is a variable. And so general form for an exponential equation looks something like this. We have y equals a times b to the x. The a is the beginning amount. So in our first example, the beginning amount was that there was 1 person that knew about the rumor. The b is the growth factor. In our example with the rumor, the growth factor was 3, because after every period, the number of people who knew about the rumor tripled. And then the exponent, the x there, is our variable, and that is after how many periods, at least for our first example. Let's take a look at another example. So this example has to do with the cost of going to college, and just the cost of a 4-year degree. And let's take Butler University. It's downtown Indianapolis, and they advertise, or at least they have advertised, that 1 year is $43,000 to go to Butler. So let's say you go for a 4-year degree. You would end up paying $43,000 4 different times. 43,000 times 4 is $172,000 for your college education. All right, so let's suppose that you took that $172,000 that you would have spent at college, and you invest it. So instead of at the end of 4 years having no money but a degree, let's say that you took your first year and, well, let's go with year 0 first. Year 0, you started with $172,000. After 1 year, now we're going to make an assumption about what you can invest that money at a good rate. And so let's say that you took this $172,000 and you invested it at a rate of 6%. Now, let's talk about 6% real quick. If I have $100 and I want to find what that money would be worth after a year at 6%, I would actually multiply 100 times 1.06. And here's why I would do that. 1.06 is 106%. What that means is I want to have 100% of my money after a year, plus I want to have 6% more. Well, 100% of my money is my money just staying the same. 6% more means that I'm going to have 106% of my money in 1 year. Well, as a decimal, that's 1.06. And so if I took 172,000 and multiplied it times 1.06, that's going to give me how much money I would have total after 1 year. And that's $182,320 after 1 year. If I wanted to figure out how much money I'd have after 2 years, I would take this $172,000 and I would multiply it times 1.06. But that would be for the first year. I'd have to multiply it by 1.06 again then to figure out how much money I'd have after 2 years, which means I would multiply it times 1.06 to the second power. And that is $193,259.20. And so we get to see a pattern, like our pattern with the rumor here. After 1 year, we multiply by 1.06 to the first. After 2 years, we multiply by 1.06 squared. Let's say that we wanted to figure out how much money we would have after 40 years, which would be about the time you retire. Our equation would look like this. $172,000 is what we started with. We would multiply it times 1.06. That's our growth factor. But we would do that 40 times. In other words, we would raise that to the 40th power. And if we took 172,000 times 1.06 to the 40th power, we would have $1,769,143 when we retired. Now that's without a college education. That's just taking the money that we would have made in college and investing it over a period of 40 years. Is that worth it or not? Well, the benefit would be that you would have that money, but then the negative part of that is you'd have to spend 40 years probably doing something that you really wouldn't want to do. Where if you went to college, you can get a degree in something that you enjoy and spend 40 years doing something that you enjoy. What is our general equation? Our general equation is y equals $172,000, which is what we started with, times 1.06 to the x power. And if we wanted to figure out how much money we'd have after 50 years, I could let x be 50, and so on. So let's go ahead and take a look at another example. Summit. Those of you who went to Summit know that you are these Summit Falcons. And so suppose that the year Summit opened up, which was 1993, they let 5 falcons go in our community. And the goal was to allow these falcons to reproduce and grow in population so that we would see more of them out and around our community. And you do now. You see a lot of falcons around. And what we're going to do is assume that the falcons double every year. The population doubles. In other words, after 1 year, suppose there would be 10 of them. Well, how did we get 10? We took 5 times 2. After 2 years, there would be 20 of them. And how did we get 20? We started with 5, and we multiplied it times 2 twice. So it's 5 times 2 squared. After 3 years, there would be now 40 of them, because we started with 5 and we would multiply it times 2 to the third power. So we started with 5, we multiplied it times 2 once, twice, 3 times. And so we can figure out how many falcons, if this were true, would be in 2017. That would be 24 years later. We would take 5 times 2 to the 24th power, because it would be 24 years after 1993. And if you take 5 times 2 to the 24th power, you are going to get a grand total of 83,886,080 falcons. Now, obviously, we don't have that many falcons around our community, because they don't grow forever at that rate. If there becomes too many, they might their population might decrease because of the amount of food they have. So the general equation with what we came up with here was that the beginning amount of falcons was 5. We multiplied it times 2 to the x power. So this is a multiplication sign here. Let's say that the population was supposed to grow by 10% per year. Then the general equation would look something like this. It'd be 5 times 2. It would be y equals 5 times 1.1 or 1.10 to the x power. Because if it grows by 10%, 100%, or if it was just times 1, would just be the same amount. If it grows by 10%, it would be 110% would be the growth factor. A growth factor of 2 means that it's a 100% increase, because if it was just 1, it would stay the same. But 100% plus another 100% growth would give you the value of 2 here. And so this is exponential growth, because what we're multiplying it by is bigger than 1. If we just multiplied it by 1, it would just stay the same forever. And so this last example here is a Chevy Vega. And let's say you bought a 1977 Chevy Vega. This is year 0 for $3,400. And the car depreciates. That means it goes down in value by 20% every year. And we want to know the value of the car, let's say 20 years later. Well, it's going to look something like this. The general equation is going to be y equals $3,400, because that's the beginning amount. The growth factor in this case, because it depreciates, that means it's getting smaller. The value of the car is going down 20%. So let's say it started out at 100%. The value of the car is 100%, but 20% goes away. If 20% goes away, that means you have 80% left, and what you're going to be multiplying by is 0.80 to the x power. And so if we want to figure out the value of the car 20 years later, we would take $3,400 and multiply it times 0.80 or 0.8 to the 20th power. And that's roughly $392 left. And so that's the value of the car in 1997. And so this is an example of exponential decay, because the value of the car is actually getting smaller. And so it's a decay of 20%, which means it's 20% less than what it used to be. If it was getting smaller by 25% per year, then the growth factor would be 0.75, because that's the value that is left after 1 year. And so these are the kind of examples that we're going to be doing in our homework assignment for tonight. And if we have questions, we will go over those tomorrow in class.